Hello everyone. Today we will be looking at bases other than e and differentiate and integrate them. The topics we will be considering is, first of all, we will define an exponential function which has a base other than e. Then differentiate and integrate exponential functions which have bases other than e, and differentiate the logarithmic functions that have bases other than e. Now, the definition of the base of the natural function, which is of having a base which is a, and it is not e. So if a is any positive real number, a not equal to 1, x is any real number, then the exponential function to the base a is denoted by a to the power x and defined as a to the power x equals e to the power natural log of a to the power x. And remember, if a is 1, then 1 to the power x is basically a constant function. There are various graphs I have made for you guys. You see, when y is equal to 1 to the power x, which is basically a straight line, guys, here. But the moment your y is not 1, it is greater than 1, you clearly see how the graphs are exploding here and exploding here. Or if the values are less than 1, how the graphs are decreasing down. These ones, guys. Okay, so let's define a logarithmic function and look at some properties. If a is again a positive real number, a not equal to 1, x a real number, then the logarithmic function to the base a is denoted by log of x to the base a, which is basically 1 over natural log of a times natural log of x. The properties, if I have two positive numbers, x and y, and n are rational, then log of 1 to the base a is 0. The product rule, log of xy to the base a is basically log of x to the base a plus log of y to the base a. The quotient rule, log of x over y to the base a is log of x to the base a plus log of y to the base a. And the power rule, log of x to the power n to the base a is n times log of x to the base a. A very important inverse function properties, guys, is that if y is equal to a to the power x, if and only if x is equal to log of y to the base a. Once again, x and y are positive numbers, n is a rational. Now, second property, a to the power log of x to the base a is x for all x positives strictly greater than 0. And log of a to the power x to the base a is basically x for all x. The most important thing for us, guys, is the derivatives for bases other than e. The derivative of a to the power x is a to the power x times natural log of a. And derivative of a to the power u is a to the power u times natural log of a times du by dx. The logarithmic properties, the differential of log of x to the base a is 1 over natural log of a times x. And differential of log of u to the base a is 1 over natural log of a times u times du by dx. So, keeping these things in mind, let's do some examples. Now, y equals 4 to the power x. So, what's the differential? It will be 4 to the power x natural log of 4. That's what it is. Now, for the expression y equals 3 to the power 2x, so y prime is 3 to the power 2x natural log of 3 times differential of 2x. Remember, it's a chain rule. This is important. Remember, a to the power x is what? Differential. Natural log of a times a to the power x. But here, notice my x has a coefficient different than 1. It is a 2. So we have to take the chain rule here. So your final answer is 2 times 3 e to the power 2x natural log of 3. The next problem, y equals x cubed times 9 to the power x. So before we start the differentials, we have to see what kind of rule we have to apply first. It's going to be a product rule. The first function, second function. So y prime is differential of the first times 9 to the power x plus x cubed times differential of 9x to the power x. So y prime is now 3x squared times 9 to the power x plus x cubed times 9 to the power x times natural log of 9. And leave it like that. Okay, let's look at more examples. Y equals 2 to the power x cosine pi x. Now, once again, we're going to apply the product rule. First function, second function. So what's y prime? 2 to the power x differential times cosine pi x plus 2 to the power x differential of cosine pi x. So the answer is 2 to the power x natural log of 2 times cosine pi x plus 2 to the power x differential of cosine pi x. Remember, it's a chain rule again. Negative sine of pi x times differential of pi x, which is pi. Okay, you can let the answer be like that. Or if you want to beautify it, we can do it. So let's do that, which is going to be 2 to the power x natural log of 2 times cosine pi x. Now this minus will come in the front. Minus 2 to the power x times pi, this is a constant, times sine pi x. Okay, let's look at this second one. Y equals log of 7x minus 2 to the base 4. So what's the differential? The differential is 1 over 7x minus 2 times natural log of 4. Then taking the differential in the numerator of 7x minus 2. So it's going to be 7 on the top, in the denominator 7x minus 2 times natural log of 4. Okay, now let's look at the next one. Y equals log of x squared minus 3x to the base 3. Notice when the base is different, you always have to put the natural log there. So it will be natural log of 3 times x squared minus 3x. This whole expression multiplied to the differential of x squared minus 3x. So the final answer, 2x minus 3 over natural log of 3 times x squared minus 3x. Well guys, you need to practice these problems. So make sure you practice them, and then it will make life a little simpler for you. And now let's go ahead, look at some problems which we have been doing so many times, finding equations of a tangent line to the graph of a function. Now these functions are exponential functions with bases other than e, or logarithmic functions with bases other than e. Okay, so what's an equation of a tangent line? It's y minus y1 equals f prime of x evaluated at x1, y1 times x minus x1. So now my x1 is minus 1, x2, y2 is y1. So the main thing is taking the differential, which is y prime, which is what? 2 to the power minus x times natural log of 2 times differential of minus x. So what do we get? Minus 2 to the power minus x natural log of 2. Now when we evaluate it at minus 1 and 2, what do we get? So y prime when evaluated at minus 1 and 2 gives me minus 2 of minus 1 times natural log of 2, which is minus 2 natural log of 2. Guys, not looking for any decimals, leave it like that. But just plug in the values in the original problem equation of the tangent line. So y minus 2 equals minus 2 natural log of 2 times x minus of minus 1. So your final answer, taking 2 here, 2 plus 2 natural log of 2 times x plus 1. Good enough. Okay. Now let's look at a problem where our function is a logarithmic function which has a different base. Okay, so once again, we need y minus y1. We're going to find the equation of a tangent line. And it's f prime of x evaluated at x1, y1 times x minus x1. This time my x1 is 27, y1 is 3. Okay, let's go ahead, plug in the values here. First we have to, find the differential. F prime of x is what? Log of 3, x to the base 3. So it's 1 over natural log of 3 times x, or 1 over x natural log of 3. So that we don't make a confusion, natural log of 3 is a number, guys, that's why. Okay, what's the function value at the point 27 and 3? So it's basically 1 over 27 natural log of 3. That's it. And after that, it's just plugging the values. Y minus y1 is y minus 3 equal 1 over 27 natural log of 3 x minus 27. You can just leave the answer as it is. Okay. Once again, guys, we're going to be looking at logarithmic differentiation. And this one, definitely, there is no way we can apply the exponential functions with the base other than a. Remember that base a was a real number. Here my base is again not a real number, but it's a variable. So in these kind of problems, logarithmic differentiation is a must. What we do is, normally we try to use natural logs, make life simple. So you say taking natural logs on the whole equation. So what do you get? Natural log of y equals natural log of x to the power x. Applying the log properties, it's x times natural log of x and natural log of y. Now we will differentiate. So take the differential. Natural log of y equals differential of x times natural log of x. So what do you see here? It's 1 over y times dy by dx. Remember, y and x are different. Equals, now this is a product rule, 1 times 2. So differential of x prime, natural log of x, plus x times differential of natural log of x. So this is 1 over y times dy by dx equals natural log of x, because differential of x is 1, plus x over differential of natural log of x is what? 1 over x. So you have natural log of x plus 1. Remember, you have to solve for dy by dx, which is y times natural log of x plus 1. Remember, change the y in terms of the x, because that's where the original problem started with. So dy by dx is x to the power x times natural log of x plus 1. Let's do another logarithmic differentiation. Now here is y equals x to the power sine x. So we're going to take natural logs on the whole equation. We get natural log of y is natural log of x to the power sine x. Or we can rewrite it as sine x times natural log of x. Now we're going to differentiate the above equation. Differentiate. So we're going to get ddx of natural log of y equals ddx of sine x natural log of x. Now remember, x and y on the left hand side are different, so you will be multiplying, taking the normal differential of natural log, which is 1 over y, and then just simply multiply by dy by dx. Now, on the right-hand side, it's a product of two functions. So let's put this as 1 and this is 2. Sine x is 1. So taking the differential of sine times natural log of x plus sine x times differential of natural log of x. So what do you see here? We get 1 over y times dy by dx. Differential of sine is what? Cosine x times natural log of x plus sine x, and differential of natural log of x is 1 over x. So you remember your final answer is dy by dx equals y times cosine x times natural log of x plus sine x over x. Okay, remember implicit differentiation? So once again we do it to find dy by dx. Okay, so now to do the differentials, you can just simply differentiate this whole equation. And what you see is differential of x squared y cubed plus differential of 2 to the power x minus the differential of 3y squared x and differential of 0. Now this is differential of 0 is 0. Now here the first function differential, it's a product of two functions 1 and 2. So we're going to take the differential of the first times y cubed plus x squared times differential of y cubed. Now differential of 2 to the power x is what? Simply 2 to the power x times natural log of 2. And then we're going to take the negative and the 3 out too. So negative 3 differential of y squared x equals 0. So this is now going to the first 2x times y cubed plus x squared times differential of not x and y, remember, are having different variables. So this will be normal differential of y cubed, which is 3y squared, then multiply by dy by dx plus 2 to the power x natural log of 2. Now the last expression has again a product of two functions, y squared and x. Once again, apply the product rule. So you're going to have minus 3 y squared prime times x plus y squared times x prime equals 0. So we're getting 2xy cubed plus 3y squared times dy by dx plus 2 to the power x natural log of 2 minus 3. Now the differential of y squared is going to be 2y times dy by dx. Remember y and x are different. Times x plus y squared equals 0. Remember in implicit differentiation, guys, we have to get all the dy's together. So I'm just going to go back and forth between the two. I'm kind of out of space here. So I'm going to start it over here, guys. So I'm going to write down the equation again. So it's 2xy cubed plus 3y squared times y prime, which is dy by dx. Then plus 2 to the power x natural log of 2. And then I will take the negative 3 and 2y times y prime times x plus y squared equals 0. Okay, now let's get first open this up. So we have 2xy cubed plus 3y squared times y prime plus 2x natural log of 2 minus 6yx times y prime minus 3y squared equals 0. Get all the y primes on one side. 3y squared times y prime minus 6xy y prime equals, get the other terms on the other side, 3y squared minus 2xy cubed minus 2 to the power x natural log of 2. Now combine y prime and get the terms all together. 3y squared minus 6xy equals 3y squared minus 2xy cubed minus 2 to the power x natural log of 2. So final answer y prime is 3y squared minus 2xy cubed minus 2 to the power x natural log of 2 divided by 3y squared minus 6xy. Okay, guys. Now, I would like you guys to practice some problems. Okay. Now let's go ahead and do some integration of exponential functions with another base. The formula is integral of a to the power x dx is 1 over natural log of a times a to the power x dx. Okay. Let's go ahead and do these problems. Now these are indefinite integrals, so 2 to the power x dx is simply going to be 2 to the power x divided by natural log of 2 plus and then c. Okay. In the next one, first of all, let's separate x squared dx plus 2 to the power minus x dx. Now, x squared dx integral is easy. It's x cubed over 3. Now, to do the next one, we do not have, remember the problem we know is a to the power x dx is a to the power x natural log of a plus c. As this is not the same, so we're going to make a change. Use the u substitution. You say, hey, u is minus x, so du is minus dx. So this problem now becomes what? Minus 2u du. So it is now minus 2 to the power u over natural log of 2, which we replace back is negative 2 negative x over natural log of 2. So what's my final answer? So my final answer for this problem is x cubed over 3, and this expression negative 2 to the power negative x over natural log of 2, and remember the final answer with the c. Okay, let's look at the next problem. It's x times 5 to the power minus x squared dx. So, as usual, try the u. Now remember, if I take u to be minus x squared, then the x dx can easily vanish off. So we say, let u be minus x squared. du minus 2x dx. Now remember, we already have x dx. So that means du over minus 2 is x dx. So the problem now becomes integral 5 to the power u times du over negative half, or negative half 5u du. So that means negative half 5 over u times natural log of 5. Now remember what would be the final answer? Just replace the u by minus x squared. So it's minus half times 5 to the power negative x squared over natural log of 5. Okay, let's look at another one. Find this indefinite integral. It's 3 to the power cosine x times sine x. So if you can change it to this thing by using u substitution, so let's u be cosine x. What's du? Negative sine x dx. Or negative du is sine x dx. So this whole expression is now 3 to the power u times minus du, or it's minus integral 3 to the u du, and it's the final answer, minus 3u divided by natural log of 3, okay, and just change the u, so it's going to be minus 3 to the power cosine x over natural log of 3 plus a c. Now we have done indefinite integrals. Let's look at definite integrals. Now 1 to 2, that's the integral limits from 1 to 2, 2x dx. So applying the first fundamental theorem of calculus, it is 2 to the power x natural log of 2. The limits is integration is 1 to 2. Remember, this is your capital F of x, so you'll be doing f of 2 minus f of 1. So which is 2 to the power 2 natural log of 2 minus 2 to the power 1 natural log of 2. So you can take 1 over natural log of 2 out, it's 4 minus 1. Final answer, 3 over natural log of 2. 2. So it's 2 over natural log of 2. One last problem, guys. Here it is like you have to write down the definite integral. It says find the area of the region bounded by these equations. Y equals 3 to the power sine x cosine x, x is 0, x is pi, y is 0. So you want to write down the equation, the definite integral equation is 0 to pi 3 sine x times cosine x dx. Okay, now let's go ahead and make the u substitution. You say u to be sine x, then du is cosine x dx. Okay, now okay, there's a mistake, guys. I think this should be 3 to the power cosine x and sine x. Sorry. Let's make the change here because this will not give the right answer here. So this has to be, I'm sorry, this was a mistake. Cosine x and sine x. Okay, so let's redo this one, the u thing. Okay, my u is cosine x and du is minus sine x dx. Or minus du is sine x dx. Now, when x is 0, u is cosine 0, which is 1. When x is pi, u is cosine pi, which is minus 1. So this expression now becomes 1 to minus 1 with a negative in the front, 3 u du. If you remember the properties, that a to b f dx is the same as minus of b to a f dx. So I'm going to use this one because the minus can cancel. So this will now become from minus 1 to 1 because the minus with the minus will cancel out. Minus, this is minus. Let me use the colors. So this minus is the one which is given, and when I flip the limits, I will have a negative in the front times minus 1 to 1, 3u du. So now I have 3u integral minus 1 to 1 du. So this is now going to be 3u over natural log of 3 minus 1 to 1. What do we get? 3 over natural log of 3 minus, remember just applying the fundamental theorem of calculus, 3 to the power minus 1 over natural log of 3. You can leave the answer as it is if you want. Okay guys, now practice time. So make sure you practice your problems and it will help you out. Oh, by the way, I think I've already done this problem for you. Number 5, I've already done it. So just practice from, number 6 I've done. So 1 to 5, guys, go ahead and practice. Thank you.